everyone, good day, geometry. We are covering CO34 today, which is actually going to be a nice piece of review. This unit, as we talked about earlier, focuses on shapes that are similar, not congruent. So they're not going to be the same shape. They're going to be similar, and we're going to be using proportions to solve for sides. Because when you use proportions, things that are proportional, they follow a scale factor. They are similar figures. So for starters here, we're just going to review how to solve a proportion. And going over the math packet today a couple times, some of you mentioned cross products. Okay, that's a great method to use when solving a proportion. It will work every single time. Sometimes there are methods that are more efficient, but cross products, if you're only going to remember one way to solve a proportion, cross products is the one. And what it looks like is it's the numerator of one fraction times the denominator of the other set equal to the denominator of one fraction times the numerator of the other. Right? So we get 2 times n equals 9 times 5, or 2n equals 45. The reason why cross products is so slick is that it gets rid of the fractions, right? And we just get one equation with one variable to solve here. And n ends up being 22.5. Okay? Should be review, right? How can you check this to verify that n really is 22.5? Yeah. Okay. So 2/9 equals 5 over 22.5. How does that prove to me that I got the correct answer? Yeah? Well, 2/9 is already in simplest form, and 5 over 22.5, that's, a decimal makes that a little bit tricky. Audrey?
You could do cross products again?
Sure. You could say, well, does 2 times 22.5 actually equal 9 times 5? If they both equal 45, then you know that you're right. What's another way?
You turn the fraction into a
Decimal values. Decimal values of equivalent fractions will always be exactly the same. So you take 2 divided by 9, you get 0.2 repeating. You take 5 divided by 22.5, you get the same 0.2 repeating, and you know that you're right. Okay? Either of those methods work just fine. So n over 13 equals 36 over 78, same kind of deal. Where students tend to run into trouble is when things get a little bit messy, such as in the third one there. N plus 9 over 2 equals 5n minus 3 over 4. We can still use cross products here, but tell me what's wrong with how I'm writing 4 times n plus 9. And this is where folks make the mistakes. What's wrong with that? Yeah.
You need to have parentheses.
Around what?
N plus 9.
Right. You are multiplying the numerator, the whole thing, n plus 9 by 4. So you need to have parentheses around your n plus 9. Your other product here, 2 and 5n minus 3, same thing. You need parentheses around that 5n minus 3 because it's the whole thing. And whenever you've got parentheses in an equation, what property do we need to use? Distributive. So we get 4n plus 36 equals 10n minus 6. We have variables on both sides. Maybe we want to move our 4n's over. So we're going to be subtracting 4n from both sides to get 36 equals 6n minus 6. And from here, it's just a two-step equation. We're going to move our negative 6 over to the left by adding it. 42 equals 6n. Divide both sides by 6 to get n by itself. And we get 7 as a value for n. Okay? Which can still be checked, right? If we go back up to the original proportion here, when you plug in 7 for n, we get 16, 7 plus 9, divided by 2. And here, we get 32 divided by 4. Both of those fractions equal 8. So we know that we would be correct. All right. Quick review, but probably a good thing we did it. Any questions so far? Hopefully the light bulbs flickered on. Okay. All right. So moving on. Down to the geometry piece of this here. Oh, yeah, no. A proportion, the definition of it is simply equivalent fractions. That's basically it. A proportion is just equivalent fractions. And we can use these equivalent fractions in geometric figures to find lengths of missing sides. And what we're looking for, it says what proportions can be written. We're looking to compare corresponding sides. Okay? So of the sides that we're given, so we're ignoring the diagonal side here, we kind of have a smaller triangle, and a longer or a larger triangle. So give me one example of a proportion that can be written involving those four pieces. Yes? 8 over 10 equals 4 over x. Exactly. We have the long side of the small figure compared to the long side of the large figure over the short side of the small figure compared to the short side of the large figure. Okay, that is one option. What's another one? Audrey?
You could do 10 over 8.
Yeah, we could flip this over. 10 over 8 equals x over 4. Still lining up those corresponding sides. What else could we do? These two proportions go from one triangle to the other, right? 8 is to 10 as 4 is to x, or 10 is to 8 as x is to 4. What else can we do? Julia? That's pretty much what we have here, that 8 over 10 equals 4 over x. Yep, it's just written opposite. Yeah.
8 over 4 equals 10.
Yes, we could stay within the triangle itself and say 8 over 4 equals 10 over x. Within the same triangle, long over short equals long over short. And then what's the fourth one that we could write here? Anybody? Yeah?
4 over 8.
We could again, 4 over 8 equals x over 10. I just flip that one around. And the reason why these are all the same thing, and if we use cross products to solve these, we'll get the same answer for every single one, is that notice in all four of these, look at the position of particularly the 4 and the 10. They're always diagonal. So that no matter how we set this up, using cross products to solve this, we're going to be multiplying 4 and 10 and then dividing that by 8 every single time. That's how we know it works. Okay? That's how we know it works. So for the triangle down below there, and we're going to go a little bit past 2:45 today. My apologies for that. If you need to leave at 2:45, get up and go and just catch the end of the video later on tonight. But in the one down here, we've got a triangle inside of another, and we're looking to solve for x, which is side BA, right? X is the entire length, is that long side of our larger triangle, BA. What's the corresponding side in the smaller triangle with BA? The triangle inside, what's the corresponding side with BA, Alan? BD. So BA is to BD, again, matching those corresponding sides. And since we started with the big triangle in our first fraction, we're going to start with the big triangle again in our second fraction, and we get side BC, right? That long side of the big triangle. And then what side of the smaller triangle corresponds with BC? Julia? BE. sometimes it's easier to set up your proportions with just side lengths or side naming sides and then plug in the lengths. Okay? What is the length of BA? Well, that's what we're trying to find. That's X. What's the length of BD? This is the tricky one. What's the length of BD? Elise? Very good. X minus 3, right? Because BD goes from B down to D, but then to get the whole of BA, we have to go that 3 extra, right? So whatever BA is, BD is 3 shorter. So if BA is X, BD is 3 less than X, or X minus 3. The side length of BC, 24. And the side length of BE is 18. Okay? And that's the proportion that you would solve. Notice you got extra stuff, that X minus 3, so don't forget your parentheses there. Okay? But then when you get your value for X, you can plug it back in and see if you get the same decimal answers. All right? Your homework for, next week, since we have Monday off, we'll have live classes on Tuesday or Wednesday. So I still want to get a live class next week rather than having 2 recorded. So Tuesday or Wednesday next week, and then recorded lesson Thursday. You will record a lesson tomorrow as well, but this homework, we won't check it in until next week at our live class. So you got a week to finish it up. But I recommend doing it sooner rather than later because what we're going to do kind of depends on you doing this. But anyway, your homework is going to be on page 360, 23 through 30. Page 360, 23 to 30, and 42 and 43. Yes. 42, 43. I do need you to show your work on this one. That SW circle is showing work. So on these 10 problems, I need work shown. Okay. Did anyone get an answer for our one we left off here? Anyone solve it out? Julia, what did you get? Yes. Well, X can't be negative 12 because that would mean that we have a negative side length here. So check somewhere where you made a sign. I mean, I think isn't 12 the answer? So you just made a sign mistake. But yes, 12 is what you should get for X. So if you didn't get 12, go back and see where you went awry. Yes, BD is 9, which means that X, which is BA, the whole thing, would be 9 plus 3, which gives us 12. Okay. All right, folks, with gusto, that's how you math.